Hey, welcome back, ladies and gents. This is going to be PN42 Part C. Just kind of taking you a step back. Part A, PN42 was when we just introduced polar coordinates and showed you how to graph points on the polar coordinate axes. Then we, on Part B, not we, me, showed you how to graph equations, some very cool ones. I hope you thought a little different anyway. And now we're getting into how we convert from something we're very familiar with, which is rectangular coordinates, over to polar and vice versa. So conversions. And we're going to start off with just drawing a point somewhere on this axis. Oops, I need to switch over here. I'm going to put it right there. And I'm going to say this is point XY. And this is going to be on a typical rectangular coordinate plane, and we know that, if I can draw it kind of carefully here, that we would, to get to that point, we'd go x units, in this case to the right or the positive, and then up y units. And the hypotenuse is this right here, and we're going to, by the way, in vectors we call that the magnitude, but now we're going to call it the radius. We're kind of going back to the idea of the unit circle. Now with the unit circle, the radius, or r, would be 1. But in polar coordinates, the radius doesn't have to be 1. We also know that this angle here we typically call theta. In this case, it would be the directional angle. So if we really want to, we could use cosine. I'm going to say cosine of theta, and we could set it up so that it would be the ratio of the opposite side, the adjacent side, x, over r. And if I solve for x, I would end up with x equals r cosine theta. That is how you convert, if you're given a polar coordinate, how you get the x value in the rectangular coordinate plane. So let me do the y is the same way, sine, but of course we're using sine of theta equals y over r. And when we solve for y, by either cross multiplying or multiplying both sides by r, you'd end up with r sine theta. So I'm going to put both of those nice little, if you want to call them formulas or whatever, right over here. And I will say that this looks very similar to vectors when we were finding the x component and the y component of the component vector. This is very, very similar, where r, instead of radius, would have been magnitude, and theta would have been the directional angle. This right here, these two, you would use if you were going from polar coordinate to rectangular coordinate. So there's what you would use to convert that way. Now if you're going the other way, well, if you're given the xy data point, you can use Pythagorean theorem to find the radius. And this is, again, if you have a component vector, you can work backwards to find the magnitude and the directional angle. This is exactly the same thing, just using the same tools for a different purpose. And then to find the directional angle, of course, you're using tangent, where you have tan of the angle equals the opposite side over the adjacent. And of course, you would do that inverse tan to solve it. This here, these two fellows right here, you're going to be using to go from rectangular to polar. Okay. And I do want to say theta does have to be adjusted sometimes, just like directional angle, where you're going to have to add maybe 90 degrees or subtract from 180, all that kind of good stuff, just like we did before. Okay, so let's see how this plays out here. So we're going to be using those formulas, if you want to think of them that way. You know how I feel about formulas, but those tools, let's call them. Okay, we have a polar coordinate here with a radius of -2 and a rotation of -5 pi over 6, and we want to find the rectangular coordinate. Now again, we know that to find the x, we're going to take the radius, which is -2, times the cosine of -5 pi over 6. This is kind of maybe where I should kind of give you the hint that you will be using your unit circle. whether it is hopefully in your mind memorized very, very well, or if you need to review it, you might want to drag it out of your note guides to check or remember where negative 5 pi over 6 falls on the unit circle. So that's negative 5 pi over 6. Just to kind of remind you, negative means you're rotating clockwise instead of counterclockwise, and you're going to end up about right here. And when you think about where that's going to fall, your x coordinate at negative 5 pi over 6, which is your cosine, is going to be negative square root of 3 over 2. So if you need to pause me right now, this video, to go grab that unit circle, or just kind of give yourself a moment to think about that, the x coordinate would be negative square root of 3 over 2, and the y would be negative 1/2. So I'm going to continue here and simplify this, and that'll end up giving you the square root of 3. So the x coordinate would be, or will be, square root of 3, and the y, if I continue working with my y here, I have negative 2 times negative 1/2, and that is going to give you the value of 1. So the point, the xy data point, or point I should say, is going to be square root of 3, 1. Yay! So that's how we go from polar to rectangular. This is the final answer. Now you can go and do the same here for number 2. It says find the rectangular coordinate at that point. Do the same exact thing and give me your answer when you show me in class. So use number 1 as a guide, and you're doing number 2 independently. Number 3, it says find the polar coordinates of negative 8 and negative 12. Well, this is different now. We have our xy point. If you want to have a visual, negative 8 is this way right here, negative 12 down this way, and I'm going to create a triangle. I'm going to try here. Wow, that was really bad. That's negative 12, and I'm not going to have room over there. So you're going to end up using the Pythagorean theorem to find that radius, or the hypotenuse. And I'm going to let your imagination do that, or you can sketch it on your own. But anyway, so you have r squared equals negative 8 squared, which is 64. So that's that x. So 64 plus the negative 12 squared, which is 144. And again, we're just using those formulas up in that right-hand box. The radius then would either be a plus or minus, because when you take the square root, you do have to realize you have that plus or minus, 14.422. We'll talk about that plus or minus here in just a moment. Now, of course, we use the tangent to find the theta. And I do want to point out, while I didn't draw a very good triangle by any means, negative 8, negative 12 is going to end up down here. That looks much better. You're finding this angle theta right in there. And so after you find it, so tan of theta equals opposite, which is negative 12, over, actually let me just double check here. We're going negative 8 over, and we're going down negative 12, and so negative 12 over negative 8, when you do your inverse tangent, you'll find that you have a theta of 56.310 degrees. Now, again, that is not the angle that we technically, well, we can use it, but we have to make sure we use it appropriately. So you have a choice here. One, you can use the radius that is positive, so you can say, hey, you know what? My radius is 14.422 with an angle rotation of, and you would add, in this case, 180 degrees all the way around, plus that 56, and which would give you 236.31 degrees. Okay, so there's one way you can represent this polar coordinate, or if you really want to be a rebel and use that negative 14.422. Now remember, negative 14 means that it's going to move the opposite direction away from the angle. So we wouldn't want to use 236.31 degrees, because that would be over, and I'm going to change the color so you really see it, be over here, and we don't want that. But get this, if you use that negative 4.422 and use the angle associated with that yellow area, which just so happens to be 56.310, you'll end exactly where you need to be. And let me kind of demo that with maybe just a different color here in a second. Okay, so if I rotate 56 degrees right here and don't go towards the degree, which is the yellow dot, but away from it, you end up over here. Because remember, you're talking about anywhere on this line right here, and you're going to end up right over here. Kind of super cool if you can get your head around that. Okay, so in example number 4, you're going to do the same exact thing. You want to find the polar coordinate of 2, -4 using the Pythagorean theorem and tangent. And again, you can write it as either a positive or negative radius, but just kind of keep an eye on that angle because that does make a difference. By the way, up here, I would definitely just have given this angle myself, or given that problem. Although, yeah, I don't know, maybe this one, because then I don't have to subtract or add the 180 to it. Either way, it's fine. But you're going to show me this example in class, obviously, and when you're doing your homework, I want you to do 2 through 4 on that section 6.4, 15 through 22, 51, but let's not do 53 or 60. Notice it says only use calc on problem 17, 18, and 51. So you're only using your calculator on these. The rest of them you will be using your brain only. Okay, so if there's any questions, we'll address those in class, but thanks for tuning in.